So you have, let's see, this is, I'm just in here right now for pre-cal. This is due on Monday. So we're going to finish up 7-1 today. And at the end of class, I'll take questions if y'all have any questions about what we're doing right now. Okay. So I'm just going to jump over here and start talking about pre-calculus. Yesterday, okay, and y'all can see my screen, right? Y'all can see pre-calculus stuff up on there right now? Yes. Thank you. This is what we did yesterday. Remember, I told you guys that you basically had two formulas. You had this formula, log base b of a equals y, and y to the b equals a, and they would just flip back and forth. And then we also talked about the change of base. So today we're going to talk about, we talked about also common log. I want to talk about another log that gets used a lot. For whatever reason, there's a log called the natural log. Natural log just actually occurs in nature. It's just something that it's the way something grows, or I'm not sure how it actually works, but natural log is one that scientists kept seeing showing up when they were trying to do calculations on things. So I need you all to write down that, let me get myself some room. Log base e to the a. And remember, e is just a number. If you look at your calculator, e is just that number, right? Let me find it. Just like how pi is 3.14, blah, blah, blah. E is 2.718, and it keeps on going. Okay, so it's just a number. So this is just a number, just like any other number we had down there. This is actually usually written, I never see it written like this. It's written like this. And there's even a button on your calculator. LN right here is on there. So you have your common log and you have your natural log. And I think it's French. That's where the L comes first. I always thought it should be NL, but it's always been LN. So LN is just another type of log. Okay, so that's what I really need you to get to understand. So if I'm looking at these, if I'm going to do change of base to this like we did yesterday, I would just have log of 20 over log of 3. Okay, that's just exactly what we did on yesterday's stuff. Now you can also go ahead and use natural log for this. So I can come in here, and if I put this in my calculator, if I came over here and said log of 20, where's my little guy at? Make sure I shut that parentheses for that one, divided by log of 3. I'm going to get that 2.727 number. If I come over here, and this is also change of base, and if I say ln of 20 over ln of 3, and I come to my calculator, I'm going to do that this time. I'm going to use the ln of 20 divided by the ln of 3. I should get the same answer. And I do. Okay. So you can use it either way. I tend to use ln more. I don't know why. But notice it's kind of, they don't cancel out. Like I couldn't use a log on top and an ln on the bottom, but it's kind of like they do. It's like I could come over here to this next one, and I have log of 2 to the 1 over 16. Now you guys know it is, if we do the old-fashioned way, equaled y. We would have 2 to the y equals 1 over 16. And that would make that number, y would equal a negative 4, because 2 to the negative 4th is the same as 1 over 2 to the 4th. And that's the same thing as 1 over 16. So if we were doing it the old way, the way we talked about yesterday, I already know what my answer is. But if I come over here just to kind of prove it to myself, and if I say the ln of 1 over 16 over the ln of 2, go back over here to my calculator. Ln of 1 divided by 16, or else I could use my alpha key, divided by the ln of 2. I better get negative 4. And I do. Let me show you real quick what happens, and I might make a liar out of myself. We'll see. Let's say I didn't close my parenthesis, and let's just say I put divided by the ln of 2, which technically is what I'm doing. See how it messes it up? So you got to have that little parenthesis in right there. Because what's happening here is the calculator is thinking you're taking the natural log of this whole thing, 1 divided by 16 divided by the ln of 2. You have to kind of, that's like a period in a sentence. You have to stop the ln right there. And that's what we're doing with these. We are just taking these and we're taking it from this to log to ln. So basically, if you have something like this, you can either do change of base this way or change of base that way. And this is just called the change of base formula. Okay. So now the last thing we're going to talk about with these is actually doing problems with them. Okay. And if you have a problem like this, before we had a number right there and I was having you put a, like a Y right there. Well, now we've kind of changed some stuff up, but we still do the same thing. We still say 9, our base, to the negative 2/3 equals X. So we're still using that formula we had way back, it was just yesterday, that we had yesterday. So now to finish this out, to get this in radical form, to find the value, that's it in rational form. But just to get it in radical form, in case you see it in radical form, the first thing I'm going to do is I'm going to get rid of the negative exponent. Okay. If I take it to the denominator, the negative goes away. And then 9 squared, the numerator stays with it. The denominator goes out there. That's like the root. And we end up with 1 over the cube root of 81. So if it wanted it totally in radical form, if I put this in the calculator or if I put that in the calculator and I hit enter, I would get the same answer for both of them. Okay. So these are pretty easy to me because you got the 9 sitting there. This looks like the log form. When we get over here to the ln one, I don't think the ln one looks as easy. And what you kind of got to think about, this is really log base e of x equals 3. So I'm going to say, just like I said, 9, my base, to my, well, for lack of a better word, the answer right there. This is going to be e cubed equals 3. So whenever I see this in my mind, I got a little e down there. Then I have to cube. And you can leave it like that. That's the exact answer. If they wanted it to 3 decimal places, it would be, oh, that's stupid. Why do I have a 3 there? It should be an X. That's approximately 20.086. But you just got to remember this. ln is just a shortcut way to write this right here. Questions for me on those two? Okay. Let's come down here. Only got 2 more screens left. We'll be quick today. Here's another one. On this one, we're still just going to take our base. This is log base 3 of 2x plus 1 equals negative 3. So we're going to say the base to the negative 3 equals 2x plus 1. And basically what we've done here is we have just gotten rid of the log part. So now I have 1 over 27. That's the same thing as 3 to the negative 3 equals 2x plus 1. And basically we have changed it into an algebra 1 problem. And I know I can replace this with 27 over 27. That's the same thing as 1. 1 minus 27. And then come in here and multiply both sides by the reciprocal of 2, or you can divide both sides by 2, however you want to do it. And I end up with a negative 13 over 27 equals x. So I'm going to give you a little bit of time to take a look at that. Any questions for me on that one?
The 3 in the log goes with the negative 3.
Yeah, what you do, you always take whatever the base is, and this is actually the power. When you put it in exponential form, this is the power that goes with it. Remember, this was like my B and my A and my y, and it's b to the y equals a when we get an exponential form.
All right. Thank you, Chef.
You're welcome. Anything else?
No, it's good.
Okay, I'm going to take a look at the next one then. Okay, ick, look at this. This is ick. The very first thing you want to do with this problem is I'm going to change this to rational form before I do anything. I don't ever leave anything in radical form. This is the same thing as 5 to the first power times 5 to the 1/2 power. This is just the square root, and this is just a plain old 5 by itself. So if I do this same base, I'm going to add my powers. I got that. So I'm going to come in here. Log base 25, 5 to the 3/2. So I haven't done anything but just change the form of that 5 radical 5. Okay, and then I'm going to say 25 to the x equals 5 to the 3/2. I'm doing the same thing I did over here. Base to the answer, base to the answer equals, they call this the argument. I call it the guts, equals the inside. So I want my value for x. This one down over here was easy. This one was just, like it's an algebra 1 problem. This one is what we just did the last chapter. I've got to get these two bases to be the same. So I can come in here to this 25 and make it 5 squared. Still got the x out there. 5 to the 3/2 over here. And remember, up here, we had two bases, so we add our powers. Down here, we have one base, so we multiply our powers. And then, just like chapter 6, as soon as you get your bases to be the same, you're just going to set your powers equal to each other. Multiply both sides by the reciprocal. And x equals 3/4. So again, let me give you a minute to look at that. See if you have questions for me. Okay, if there's none. I've got 2 more examples to do, then we're done. Okay, now we're going to take a look at this one then. Again, the same thing is happening. Base to the answer equals the inside. And right away, I have a problem. There is no way that I can make 9, like 2 to who knows what power, I don't know what power it is, equals 9. I know 2 to the third is 8. And I know 2 to the fourth is 16. So I know my answer is somewhere in between my answer to this side is somewhere between 3 and 4, but I don't know what it is. So what I'm going to have to do is I'm going to have to go to my calculator. And I'm going to have to go to y equals. I'm going to clear out what's in there. I'm going to come up here and I'm going to say 2 to the x plus 2. Now be real careful right here. I'm coming down out of the exponent minus 9. And what I'm looking for here is where this crosses the x-axis. Where this crosses the x-axis is my answer. So I'm not real sure. I know the numbers aren't going to be real big. I know I got this 2 here. That 2 there is going to mess something up. Because what this is telling me when I talk to you about this, 2 to somewhere between 3 and 4 is my answer. So what I'm going to be doing, what the calculator is going to be doing, it's going to take and it's going to do this. And whatever this answer is, it's going to subtract 2 from it. So if I look at my calculator, I'm just going to hit zoom 6. That's how I always start, just to, if I don't really know where to start. Okay, and I got an answer right there. So second window, alpha window, I'm sorry. Alpha window. Clear it out. Let me start over again. Maybe it's alpha y equals. No, alpha something. I'll find it eventually. Let me get my graph back. I want to find that 0. Somebody who can help me alpha trace, alpha zoom.
I think it's second trace, and then.
Oh my gosh, you're right. I'm stupid.
Yeah.
Yeah, I am. You can say it. That's okay. I was stupid. I don't know why I was doing alpha. Okay, second trace. That's what our calculations are. It says it right there. I want the second one. My left bound, I'm just going to say is 0. My right bound, I'm just going to say is 2. And do I want it to guess for me? Yes, I do. And my answer ends up being, it looks like 1.670. So I'm going to go over here from that. There's my answer right down there. X equals 1.170. Let's look at that again. 1.1. And because I got that 99 there, I'm going to round that up to 7. So that is my answer for that. That's what X equals. But the key is what you got to make sure you know, as soon as you see this, as soon as you rewrite it and you know there's no way that you can change, there's no 2 to no integer number that you know of gives you 9, immediately that needs to, right here, this needs to tell you this is a calculator problem. Because there's no way to do it by hand. Okay? Do this last one over here. Again, this, to get rid of the ln to rewrite it, like you put a little e down there, and you're going to say e to the 5th equals x plus 3. And then if I want x, if I want the exact answer, there's my exact answer. That's the best answer you can have. But if they want it into 3 decimal places, once you get used to E is really pretty nice. It always, it's like, to me, that last problem I just did in black right here, that was a heck of a lot easier than that. I am done. That's all I'm doing with you guys today. Don't get off quite yet, though, because there's a couple things I want to talk to you about. Make sure, let me see how many people showed up on here. Okay, 16. I'm going to start calling home to parents of people that aren't, I'm going to give you this homework. If you all don't have this homework turned in, I'm going to start calling home to parents, because you have got to be doing this, because honestly, I think we're doing this the rest of the year. And we had a meeting with Mr. Bogard yesterday, and he said, if you haven't already started, NTI needs to be forward thinking. I mean, teaching. So you've got to tell more people to either get on here or watch the video later on. I don't care if they watch it later on, but there's 60 of you all, only 16 of y'all showed up. So make sure you're telling the people around you, because we're going to have tests. The tests are going to be randomized. We're going to have, and I know that you'll probably work together on stuff, but you still need to be getting this stuff done for me. And just come over here and look real quick. Okay, I'm done with new materials. So if you don't have any homework questions, that's fine. You can leave. If you have homework questions, please ask me right now, and I'll go over a couple of them while people are here. Nothing? So y'all are good with this? You all are good with, which one messed me up? You all are good with that kind?
I wasn't good with 8.
Okay, let's take a look at this 8 right here. Let me take a snippet of it so I can put it over on the notebook. Shoot, I got it up here. Calculus, here you guys are. Okay, here's 8. And somebody asked me to do 8. I'm going to tell them to come to this video and look at it right here. Okay, on 8. This is what you got. And like I told you guys, the first thing I talked about doing with this is first rewrite it as an exponential. Well, you got 2 4s going on here. You got to do something with. So this is like 4 times 4 to the 1/2 power. So if I'm looking at this, I'm going to say 4 to the answer equals 4 to the first power. You don't put it, times 4 to the 1/2 power. So this just stays the same. We want 1/4 on each side. So basically we're going to take 1 plus a half. We rewrote as equation with identical bases. So x equals 3/2.
Okay, thank you.
You're welcome. Anybody else? Okay, I'm going to stop the video and I will have it saved. Yesterday we had some technical difficulties with the video. I'm hoping today you'll do it better. Please have some patience with me. If you can't see it, email me and I will help you with it and we will get the technical difficulties figured out. Hope you guys have a nice day. Bye.